question 1 is just f dash x, like you just put into your CAS, you can do it by hand. You get 2xe, 2x to the 3e x squared. The nature of the stationary point, you can just graph it and make sure to write local min. When you graph it, it looks like something like that. But if you don't write local min, it's technically not wrong in this case, but it would be wrong if the graph looked like this, because then it wouldn't be the actual minimum. So if it's asking for a stationary point, then you always have to write the local word before the minimum or maximum. For find the maximum value of f, you could just put this into your CAS, use f max, or you can diff it and equate it to 0. I think the graph of this looks like this. But yeah, so it equals the maximum at 2 points. And so find values of d for when this is always negative. So if this is less than 0, then fx has to be less, or I should write the other way. So d is less than negative fx. Oh, okay, I'll just show it via graph. So basically you have to bring this graph down enough so that it's always negative. So what you do is you translate it the more further down than the maximum point on the graph. So the maximum point we calculated was 1 on E. So D is is it less than 1 on E? Let me check my E. Oh, so D is less than, and then again negative 1 on E. So finally cutting into the tangent, you just put that into your CAS. You should get 1 on E, but you could also see from the graph, like the maximum is here, so it would be like that. And then find the enclosed area is the next part, so that would be here. You can do that through your graphing menu or integration 1 to -1. 1 on E minus fx dx. Since it's asking for decimals, it doesn't really matter which way you do it. We should get 0.3568 units squared. Always good to write units just in case. So mn, find the minimum. So distance is your x minus x1 and then y minus y1 squared, like your Pythagoras theorem. So 0 minus m squared plus e minus n squared is your distance, but mn is a point on the same graph, this one. So n can be written in terms of m, so it's just f of m, and you can do that on your CAS. Oh. And then you get d is m squared plus 1 minus m squared e m squared, or something like that, but you just diff it and equate it to 0, and you'll see that it happens when x is .783, so that's your m value. You get 2.511 units. And that's question 1. So question 2, find dy dx. For 1 mark, just put it into your CAS because you don't want to make a silly mistake, and it's quicker. So 2700 on 200, 1000, and then state the set of values for which the graph is strictly decreasing. So if the graph, not the graph, the gradient. So that's important because if the graph was decreasing, then you just get from 10 to 30 because that's when it's going down. But it's actually asking when the gradient is decreasing, so you have to graph this function, and it's just a parabola from 10 to 30. So strictly decreasing, you can see that's when it has a negative gradient, so up until this point. But we can't go back before x is 0 because of the domain. So when it's strictly decreasing would be from 0 to 20 because the turning point is 20, the x value for that at least. So the height of the cable above the horizontal axis. So you can see from the graph, and they also told you that the cable is 3 meters above the hill. So any point here is 3 meters above this line, So if it's asking for the height of the cable from A to 30, then you know it's just going to be the equation of this line here plus 3. So that's 3x minus 30 squared 2000 plus 3. So find values of x for when the gradient of the cable is same as the average gradient. So the normal gradient is just h dash x, and the average gradient, they worded it as average gradient, but it's just asking for average rate of change. So that would be f30 minus f10 on 30 minus 10, and this is actually -3 on 10. So you can just equate h dash x to -3 on 10, and you should get 20 plus or minus 10 root 3 on 3. I think the answers have it as like 60, but that's the same thing because they just simplified the fraction. So next question, gradients smooth and continuous. So state the gradient at A in terms of A. So if the first part or thing to notice is it's asking in terms of A. So problem you're gonna have is with B, but it's okay because we know it's continuous. So that height function we found before we can use that to find B. So B is actually HA, and it's asking for the gradient of the straight section. So the straight section is just this. So it's asking for the gradient of this, and that would be rise over run, and it's negative, so it's negative rise over run. Or you can do like y2 minus y1 x2 minus x1, but like you can just see. So this would be 10 minus b on a, but negative. So you can sub in your a and your b, yeah, and make sure to have b in terms of a from the first equation. I got I got 3a squared 2000 100 minus, but I think the answers have it simplified, but it's the same thing. Okay. So find the coordinates of A with each value. So for this question, we use the continuous part of the information they give us. So for part B, we're going to use the smooth information. So if it's smooth, the gradients are equal. So we found the gradient of the straight part, and now we need the gradient of the curved part. So that would just be f dash x at A. So it's just f dash A. And if you equate those two things and solve for A or X, it gets a bit complicated if you leave everything in X in your CAS because it might not solve for it. So I just like to rewrite everything as X. It takes a bit of time extra, but saves you more if your CAS stops working. But anyways, A is 11.12. And if you put that into your FA function, B is like 8.95. So find the value of the gradient at A. So it's basically just f dash A, and that's -0.1. So this question 2, question 3. So state the period of the function. So this is when you don't look at the equation, don't do that for this, when you have two different functions with two different periods, don't look at the equation because that won't help. In this case, it doesn't. Well, actually, it's the bigger one, but you might get confused with the other one. So you look at the graph and you look at where it starts repeating, so you can see it repeats in giant blocks like this. And then the time between each block is 12, so the period is 12. So find values of ft. So if you look at the graph, it's easily 0, 2, 4, and 6. But in checking time, always check this type of question because you never know if this is actually at 4 and 6 and 0. They might try to trick you like that. But yeah. Like first time around should be fine to just put those values like that. But always check later if you have time. Oh, sorry, it's not 2, is it? Just, yeah. So find maximum strength. That's just F max. You can put that into your CAS, or you can let F dash T equals 0. But it is 1.76. So find the area between F and the horizontal axis. So that would be this one. So you would just do integration of what is your ft dt minus 6 to 4 ft dt, because this area would be negative, so you want to add a negative to make it positive, and you should get 15 on pi. So this question is a good one. So it's saying that you do something to it with this matrix, and then the area you calculated in this question is the same as this area. So this is actually not a calculus question. This is the pure transformation question. So what you have to do is you look at these intervals, and you might notice that it's a bit weird because why is this going from 0 to 2? Because usually your intervals should go from a higher value to a lower value. So then you realize it's going to be x to 2 dt with the g in it minus 2 to 0 g dt. And then you can see that they've done that because this area would be negative. So if you look at the graph, the area we calculated before was this area here, this one, and now it's saying that we get the same area even though we changed the matrix, except now it's from 0 to 2 and 6 to 2, except from our little algebra back there, we know that 0 to 2 part is going to be negative. So the obvious way to think about this is to go like this, because we know we have to have the same area, but it's going to be a different graph, and it's been translated and reflected, so and dilated, but in this case, it's not going to be dilated because the area is the same. So if you dilated it by anything other than 1, the area wouldn't be the same. So you know that either A and B are equal to 1 or negative 1. There can't be anything else because the area has to be the same. So you have this graph, which is the original, and the transformed graph. So you can see that this transformed graph has been flipped vertically with the other one. So it's been flipped in the y-axis, and that's your A value. So A is -1. But if you actually flip it in the x-axis, it looks like this. And so you have to move it this way for it to actually be the same as the area that we calculate. So you have to translate it 6 that way. And the thing is, you could also so you could also, if you imagine continuing this graph, it would look like that, but it could be any of these areas. It's the same. So you can translate it. Oh, sorry. I'll just erase this. It's not erasing, but anyways, so your first translation to get it to here would be +6. So you have to have at least +6 to get it to here, but then you can add more to get it as the other ones on the continuation. So you could add any amount of periods. So that's why the C translation, which is the horizontal translation, is you have to move it 6. So you have to move it 6. So it's 6, and then you can add any amount of periods. So you can write it as 6 plus like in like normal trig, you add a variable or something like that to create a general solution. So it would be 6 plus 2 n, where n is an integer, positive one, be this one. Yeah, and you can see that y is not being moved up or down, because again, if it had been moved up or down, then the area wouldn't be the same. So the d is 0, and nothing's pretty much happened in the y direction. So b is 1. It's kind of a weird question, because like you probably wouldn't think to draw your intervals on the graph first thing, and you might try to do it by calculus, but probably wouldn't work. It might, but it would probably take a long time. And then yeah. So this question is bounded by a rectangle. It's positive, and it's between 0 and 12, and has the same area as the one we found in part D. So part D, we found the area is 15. Oh, so for one period. So part D is not actually the area we need, because we only found from 0 to 6, but this time it's asking for a whole period. So that includes these two. But you can tell from symmetry, it's just twice of the area we found in part D. So the area is just 30 on pi. But if you don't see the symmetry, you can just do calculus again, but again, it might take a while. So the area we need is 30 on pi, and it's going to be a rectangle between 0 and 12. So like k times 12 is 30 on pi. And you can just suffocate, and it is 5 on 2 pi. And that's that question. So the probability question starts off pretty simple. It's just mean life. So we know mean is integration 5 to 1 fx dx, and that is 10 on 3. So now there's a sample of 90 birds. Don't get confused by the word sample. It doesn't automatically mean sampling, but yeah, usually you can tell, because they'll tell you how much was in the total population and then how much they took out of it. But in this case, they're just saying they had 80 birds, so it's not sampling. Yeah, so just a normal question with n equals 80. So how many butterflies are expected to live longer than 2 weeks? You need to figure out what's the probability that they'll live longer than 2 weeks. So the probability x is greater than 2. You can integrate this. You get like 0.9326. So if that's the probability that a single bird lives for more than 2 weeks, then for 80 birds, it would just be this value multiplied by 80, and that's to the nearest whole number, it's 73. So what's the probability a butterfly lives for 4 weeks, given that it lives for at least 2 weeks? So probability that x is at least 4 or bigger, given that it's at least 2 or bigger. And using our like expansion, we can rewrite it as this. You can just integrate that and you should get 0.2878. So the wingspan in town A is normally distributed, so now we're moving away from binomial that we were in before. And find the probability that wingspan is between these. So this is just continuous CDF between these two values, and it's like 0.1512. So now they're giving us some descriptions. So there's a butterfly. It's very small if it's in the smallest 5%. It's asking for the maximum value in centimeters to be considered a small butterfly. So information they're telling us is if a butterfly is less than a certain value, then it's in the smallest this in the smallest 5%, so 0.05. And we want to know what this A value is. So I thought like we pretty much have everything except for A, and one thing we can use to find A would be standard normal. So you find the small z value for which you get the same probability. So I got negative 1.666. And now we can convert using the formula. So mu we know, sigma we know, and z is this one. So you can find A. So A is 10.6 to the nearest one decimal place. So part F, they're saying now we're talking about very large, and there's a sample of 36 of them. Again, not sampling just because they say the word sampling. Very large if its wingspan is greater than 17.5, and they tell you what the probability of that is. So find probability that 3 or more is very large. So probability x is greater than 3. When they give you a sample, that's a good indication that we're moving back to binomial distribution. So yeah, just things to note, because the question started from binomial and then it went to continuous, normal distribution, and now we're back at binomial. So probably x is greater than 3, just n is 36, p is 0.0527, and your CAS should give you the answer. So find probability that n or more butterflies in random sample is less than 1%. So find the probability that, I'll just say x is amount of butterflies. So find the probability that x is greater than or equal to n is less than 0.01, because that's 1%. Like usually with these questions, you want to just make this equal so you can solve for it first. This question, actually, there's no way to do it other than trial and error. So if you're doing it by hand, which is the hard method, you can do like stub n is 1, n is 2, n is 3 using like the same method you did to solve for this one, and just wait until you get a value that's less than 0.1. But there's also a function on the CAS. So the easiest way to do it is to go into your normal CDF, the one that you would usually use, not normal, binomial. And then the one that you would usually do to find this, so you have your lower limit, so that would be, your lower limit is what we don't know, so it's x. But your high limit is 36, your trials is 36, and the probability is 0.0527. So you press enter in your main menu, and this will give you an error or something. It won't work, but what you do is you highlight this, so you copy and paste it into your graphing menu. Seems weird, but you take it to your graphing menu and you paste it as a y equals function, and then you press on that little icon. It's like this, and that will give you a table of like this, the n values and their probabilities, and you can just scroll down to find which ones less than, well, the first time, like for the which value of n, it's less than 1 for the first time. And it happens at 7. So n is 7. So yeah, this is a trial and error question. Just highly recommend using your CAS. Otherwise, it'll just gonna take forever to. Oh, so now we've actually gone to sampling. The P, it's a very obvious sign. So now, again, proportion, like just be aware of the words they're using so you know what type of probability that we're dealing with. So now there's 36 butterflies, and we have a proportion. So find the expected value and standard deviation. So we know in sampling, the expected value is just P. So our P value from before is 0.527. And standard deviation, we know the formula for that is P on N, 1 minus P. So P is this one, and N is 36. So if you put that into your pairs, you should get 0.0372. So it's a probability that the sample proportion within one standard deviation is, well, what's the probability of that? So within one standard deviation means P is between like you know, in your normal distribution graphs, how you have your mean. So this is asking what's the probability that it's 1 sigma to the right or 1 sigma to the left. So this whole area. So it's asking what's the probability that P is between 0.0527 minus sigma P hat and then plus sigma. So that's if you add or simplify or whatever. P 0.015. There's more decimals, but just keep it on your CAS because more decimals, it's more accurate for the final answer. So now we have our probability thing that we need to find, but we can't because it's in terms of P. So we have to convert it to X, and to convert it to X, we know we have to multiply by N. So you can multiply these two values by 36, and you should get approximately 0.55 and 3.37. But you have to remember that we're dealing with butterflies. So, well, you can't have like 0.55 of a butterfly. So you have to make these whole numbers. So if X is greater than 0.55, then X is greater than 1 butterfly. And if it's less than 3.37, then it's less than 3 butterflies. And we can't use normal approximation. So like, do not use mu and sigma as these two values. So if we can't use normal approximation, we have to use binomial. So you can put this into your CAS binomial. N is 36 and P is 0.0527. And you should get 0.7380. Yeah, so now it's asking for, it tells you what the confidence interval is, and it's asking you for the sample size. So the confidence interval is 0.023488866, and we know to find the confidence interval in sampling, we use the formula 1.96 times sigma plus 1.96 times sigma, and then sigma is your P on N, 1 minus P. So what you do is you get, so this value has to equal this one, and this value has to equal this one. So you have your two simultaneous equations. P hat minus 1.96 square root P on N, 1 minus P. or you don't actually need simultaneous equation because you know what P is. P is 0.0527. And you can just sub that in here and solve for n. And if you didn't know P, it wouldn't matter because you could use the other one as well to get your second equation, and then simultaneous equations you could find P and n together. But if you do that, you get n is 199. Oh, actually, sorry, no. Yeah, that makes sense. You do need to find P because this is not P. That's why I did it. Yeah, so there's different towns, so they would be like insinuated that there's a different probability. So if you do that in your case, you get P is 0.055. It's a different value. It's close to the other one, but it's not the same. And n is 199.95, but it's asking sample size. So you can't have, again, like this much of a butterfly. So you round it to the closest number, which is 200. And that's the probability question. So last question, there's a cubic, turning point is here, and it's asking what's the equation of the tangent at x equals a. So very easy, you can just do it by your CAS. There's the function tan line and the white CAS if you go into the calculation menu. So this would be -3a squared x plus 2a3 plus 1. So find the x coordinate q of q in terms of a. So this line is the tangent line that we just found, and you can see q is the x-intercept. So at the x-intercept y is 0, so you just let 0 equal the tangent line, and you can solve for x, and you should get 2a on 3 plus 1, 3a squared, or like you might have found it with a common denominator. Either way. So find the x-coordinate of P in terms of A. So P is here. So at that point, the tangent we found is equal to the graph of f. So you let y equal fx. You should get -2a and a, but a is this point, so we're not going to use it because it's not asking for that point. So x is -2a. So a is a function that determines the total area. So the total area of the region that's highlighted is what's grayed out, but you have to be careful because at this point, or like your first thought would obviously be do this function minus this function, and that would be correct. But that's only correct as long as the functions are actually like on top of each other, I guess. But from this point on, it's no longer this function, it's only this function. So when you do your area of y minus fx, it's from here 1 to the value of p, which is -2a. It's not from q to -2a because the graph of fx doesn't affect the area here. So your area is 1 to -2a y minus fx dx plus that little triangle. You can integrate it or do it as a triangle. But if you do it as integrate it, it's like this. And if you put into your CAS, get something. I got this giant equation. The answer simplified it a lot, but if you got this, this is also the right answer. Is it to the power 3? Could be to the power 2. I'm sorry, can't read my handwriting. So find the value of a for which a is maximum. So let a dash equal 0, this equation. And you just get a is the third root of 10. So this question is probably the hardest on this question. So find the value of b for which the total regions is a minimum. So now we're dealing with f inverse x. The tangent at a point b and the vertical axes. So if you ever see a question where it's like, they ask you for area of the normal graph, and then all of a sudden they bring in the inverse graph, just be like 9 out of 10 times, they're gonna end up using your area for fx to find this area. So the actual area that they're asking for, if I pull this out, so the area they're asking for is, if you draw, say 1, 1, this is an ugly graph, but kind of like that. It's a bit okay. I can't graph things, but yeah. So that would be kind of what f inverse x looks like. It's a cubic on its side, I guess, and it has its turning point. Point of inflection here. So, and then they're saying there's a value of b from somewhere here. So we'll just say b is here for convenience. And then it's asking you for the area of the tangent to the horizontal axis, or no, the vertical axis. So draw your tangent like this. And the vertical axis is here. So you can see the area they're asking you for is this part and this part. You don't stop here because it's the vertical axis, and f inverse x with its tangent. So you can only include the points where those specific graphs intersect. And if you see this, you can see like it's exactly the same as the gray area. So that's like symmetry, because you're doing the same thing to the other graph, just with values and x and y swapped. But that's the big hint, but that's not the answer. It's not asking for the area, it's asking for the value of b, for which the area is a minimum. So the area is a minimum for this. So the thing to realize is, when the area of f inverse x is a minimum, then that has to be related to when the area of A is the minimum. So when the area of A is a minimum, little a is equal to 1 on 3 root 10. But this is asking for B. So B is like here somewhere. But B is actually this value, because so if the graph of fx is a minimum at a something 1 minus a 3 1 minus a to the 3 something, then the graph of f inverse has a minimum at the swapped version of the coordinates. Because if you think about it, the area you're finding is the same, but on a different axis. So you just swap x and y. Area is just a minimum. So it's a minimum at the point of A. So we have to find what like the y value is. So if you put this in, then you get, sorry, it's not A, graph of f, you get 9 on 10. So that's B. So find the value of the acute angle between tangent of the graph x and the tangent of the graph f inverse x. So your graph f inverse x, as I said before, it's a side-on cubic, and this is a point of inflection. So the tangent at x equals 1 would be a straight line down. So the angle here would be 90 degrees. I'll just erase this. Oops. So straight line down. Oh, erased the equation, but yeah, if this is your f inverse x, and then it's the tangent of the graph of f at x equals 1. So the graph of f is like here, so that's your other line. And then the angle between them, so this angle. So, yeah. So, how do I guess I'll just like do this question over there. So this angle is 90, and we want to know what this angle is. So the one thing we know is tan theta, or I'll just write it as tan inverse m. So m would be the gradient at f of 1. So tan inverse f dash of 1, and f dash of 1 is actually 3. So tan inverse is -3. But if you don't have it in, like, if you don't know what this angle is, because when you calculate tan inverse of -3, it won't give you this value, because if you look at your like unit circle thing, tan inverse is negative in this quadrant and this quadrant. So like you're either going to get a giant angle or an obtuse one. So you can see that it's not going to give you the angle you want. And if you like solve for tan with no standards, whole numbers, you see that it's like 70 degrees or something. And so what I did was I found what the 70 degrees was, and it was this angle here, this one. Oh no, this one. So this is a bad drawing, but this one, 70 degrees. But we want, no, this one, 70 degrees. So, but we want theta. So, like this whole thing is 180 degrees because it's the same tangent. So then theta plus pi on 2 plus this 70 degrees, but if the question's asking for whole numbers, so tan inverse and -3 is pi, because 180 is pi. So if you rearrange that to find theta, pi minus pi on 2, so this pi on 2 minus tan inverse 3, and that's your answer. Yep, and that's the last question. Yeah.